Hello friends and followers. So I picked up this SBE transceiver, the SBE-36, and this was from Chuck in Paris, Texas, who sells things on eBay. He has a billion radios in his garage and various places. Anyway, this is an SBE-36. It's not the one that this picture is not the one that I bought, but in researching this radio, it was a pretty interesting history in that this SBE-36 was not really made by sideband engineers, but sold by them. They basically OEM'd a radio from Japan, and I think that was called a Robin 500. Anyway, this guy is in Japan. He wrote a whole web page in Japanese on this radio and some of his restoration projects. So I use Google Translate to take this Japanese to English, and so I'm able to read what he was writing about. Interesting guy. So he's saying that this radio was called a digital 500. 500 watts final output, which is what this thing does. And direct reading. So Robin Digital 500 in QST. So this might be the same radio as that. I'll have to look that up. Interesting. Boy, this thing cost a bunch of money too. $2,000 back in the day. So I guess a digital 500 cost $1,000 back in the day. At any rate, he talks about these receivers or these transceivers, and he goes back and says SBE chose the digital 500D, and the selling company then was called Linear Systems in Watsonville, California. So in '72, SBE and backed by Linear Systems. So improved by SBE, that's interesting. The Robin Hood Digital 500, priced at $8.95 back in the day in '72. So it had a real frequency readout. So they're saying the SBE-36 was made in Japan, and it sure looks like it. It has Japanese quality. So yeah, I took the one here at home apart. I don't have the power supply for it yet, but I was thinking about converting a power supply to work with it. I still may do that, but I'm not in any hurry to do that and make mistakes. Yeah, the manual for this thing's a nightmare. Additional modifications, that's for sure. So yeah, this history is really interesting. The SBE-36 reduced in price to $6.99, that it was struggling. Interesting. So May '74, the price went down to half. And here's a schematic, which is a real schmozzle. Hybrid, yeah, this thing is hybrid. And you can't run the receiver simply on 12 volts. It seems like it wants 20 volts in many of the circuits. It has a 20-volt regulator in it. Yeah, not designed by SBE, so the fact it is hybrid is sort of bad. I thought I could run this thing on 12 volts directly and use the high voltage for the transmit if I wanted to, but that's not going to happen. So I'm going to have to get the whole power supply up and running to get it going. Interesting, huh? Yeah, so for receive, it's going through a SBE-36, which is what the Drakes do. So that's not going to work for me for 12 volts. 6BZ6 goes into a 6AW8. That's a tube I hadn't heard of for a long time. So this has a VFO that goes from 5 to 5.5, just like the Central Electronics and like the Drakes do too. And it has HFO oscillators, much like the Drakes. The VFO in this thing is really well done as far as the gear network. Anyway, I'll put up the radio soon, the one I actually bought. But I've been going through this to see if I could have some luck with it. Isn't that something? Linear systems. Yeah, so the power supply, good luck getting a hold of one of those. It's a pretty power supply. It matches radio with a silver front. If I could find one. So yeah, this guy's review in Japanese that I converted to English is really cool. He has a lot of stuff on it. He talks about the audio amplifier. Looks like he had trouble with the DC. This little circuit over here, looks like that was blown up for him. It wasn't putting out 20 volts. So I tried injecting 20 volts in that circuit to see what I can get. And it seemed like some things, the S meter was kind of working a little bit as far as it was simply moving, so. But without the front end working, I'm not going to get anything through this thing at all. Anyway, it's a great little treatment he has to the radio, and I wanted to capture this stuff so it won't get lost. There's the VFO and the gear works. It's really well done. I'm not sure who Pogo is. I hope that's not his kid. I don't want Pogo to get shocked. So yeah, he goes into this stuff pretty heavily, which is something I'll need to review. And there we are. All right, so that was what I found on a blog on the SBE-36. And there's also additional stuff here. If I could find out where I put that. Yeah, here we go. So this guy is really cool in Japan. He also made a manual for it. He remastered the manual that I guess he found somewhere, and he put all this stuff into a manual. So it's pretty impressive. So Linear Systems, Watsonville, California. Yeah, the radio that I have looks like it's missing two of the filters, so I'm not sure if that was they were pulled out for parts or whether they're not needed anymore. I bet they were pulled out for parts. Anyway, kind of cool. But you'll see when I get down to the relevant areas, the schematic on this thing is pretty hokey. I'm going to skip down to the schematic and show you how bad it is. They do have the theory in here pretty well, which is good to help somebody fix this thing. Theory of operation, so there is some documentation, but the schematic is horrendous. They do have, yeah, so here you realize that you're going through tubes for the front end, which, in the mixer, which pretty much shut me down as far as trying to run this thing without a power supply by injecting 20 volts into it. That didn't go anywhere. So I need to get a real power supply working. Anyway, we'll come across the schematics here pretty soon. It's horrible. It's a pretty cool little radio though. Anyway, there's a guy on YouTube that has himself fixing one of these and a few of these. He goes into lots of good detail. I really wonder if I really should have taken up this project. I was dubious about it. The radio came in worse shape than I thought. The front of it looks nice, but the insides are really dirty and it's missing covers and all that kind of stuff. Oh, a lot of parts. I'm trying to get down to the schematic parts here. Here we go, block diagram. That's for the counter. The Nixie tubes are actually just a frequency counter, so that's what these are all for. And then things get hokey. Here we go into all this crazy stuff that's all handwritten. So they actually have drawings of the boards and what the parts are in here, which is rather maddening, but I suppose it suffices. A better way to do it would be take a picture of the board, but I guess this works. So yeah, I have this filter here, I'm missing this one and this one. So I may not even have a working radio here, I don't know. Tubes and transistors on that board. Transfer receive RF amplifiers. Here's some of the audio stuff, so I've already got another radio somewhere. Audio board stuff. But because the schematic is so bad, this one's going to be hard to fix. Here's the display board for Nixie tubes. What's this board? Oscillator board, limit lights. Voltage rectifiers. Is that for the 20 volt board? Oh, it's the power supply itself. 20-volt regulator. Okay, there we go. This guy says that board is troublesome. And that's about it. There's some diagrams here. So it looks like the power it needs from the power supply. 800 volts, 400 volts. I can get these two, I think. I can get the minus pretty close from the power supply that I have. The tempo power 1. This one I can probably get. This one I probably got to put a transformer in it. And this one's easy to get, so I think this one just goes down to that 20-volt regulator, so I could probably just put a, I don't know, I gotta redo that regulator circuit, it's awful. Looks like I need 30 volts DC. Yeah, this isn't looking so bad to get a power supply running for it. And what's this? This is that regulator board. And so, what are they doing there? They want 20 volts for the radio. And this is rectified, or this is actually regulated inside the radio. So, a 20-volt regulator chip. I guess they have a 15-volt regulator chip. So 30 volts coming in from that power supply here. DC 150 in. Why do they need this? DC 150 in. They go through a resistor. Here they're saying 22 volts. Not sure why they need that at all. Okay, this is making 13.2 volts here. I guess for that Xenier. They feed that over to here. And that's simply going out to here. Okay, wait a minute. This is a source, so it's using this voltage. $20 volts are coming down here. Weird. So no, it's getting fed here by 150 volts. It gets 13 volts out by, I guess, this diode. So there's a regulator here. I guess this is implicit in setting this voltage here. They must use that as some kind of reference voltage. So the base of this gets changed here in this voltage divider. And that feeds back to here. That just doesn't make sense how it works to me. This thing looks like an PNP. Can't tell. Strange. If this just wants 20 volts out, there's probably a better way to do this. I would think, simpler way. 30 volts in here. 28, 21, 20, 21. Okay, well, I'm lost. He's got a picture of that board right here. Troublesome board. Yep, there's the 20-volt board. DC, what the hell? All right, thanks for watching. Have a great day. Yeah, that seems like I could blow lots of stuff up putting in that DC. All right, take care.